All right, so today we're going to cover this review topic. We're reviewing factoring and solving equations, and it's really actually introducing or extending the concepts of factoring that we've done, hopefully, so far, and then just solving some equations that review some other types of factoring. So greatest common factor in terms of your sort of algorithm of factoring. We're introducing kind of something new here. So you know that when you do a greatest common factor, you look at each of your terms and you say, well, what's the greatest common factor in terms of a coefficient? So you take that out in terms of the numbers. And then when you're looking at the variables, this is kind of the key idea. When you're looking at the key variables, you take the variable with the smallest exponent. Right? That's your common factor. Right? So hopefully that's nothing new. Right? But this is the concept to really reinforce. You take the variable, or actually it's not so much the variable, but the factor with the smallest exponent, and then when you divide, what do you do with those exponents? Right? So like in this first one here, x to the power of 5 plus x cubed plus x. I look through there and I say, well, the smallest exponent is the 1. So I want to divide out that common factor of x to the power of 1. Okay, and so when I do that, what do I do? So when I'm dividing x to the power of 5 divided by x to the power of 1, what do we do with those exponents? We subtract them, right? So 5 minus 1 is going to give us x to the power of 4. So when you divide, subtract the exponents. And those are basically the two key concepts about greatest common factoring. So we're going to get x to the power of 4 plus x squared plus 1. And then if we could, we'd try and keep factoring this x to the power of 4 plus x squared plus 1, but it will not factor down. Okay. So looking at the second one, well, now we've got something a little bit different here. Right, we've got negative exponents. So kind of the push here is to now introduce common factoring where you've got negative exponents and rational exponents. Right, so just some practice of doing this kind of greatest common factoring, where the two steps are really the same. Right? It's kind of same old, but a little bit new. So 2x to the power of 5 plus 6x to the power of negative 4. What I want to take out is the common factor in terms of the number, so that's going to be 2. And then I want to take out the variable that has the smallest exponent. Okay, so that's going to be x to the power of negative 5. Right, because negative 5 is smaller than negative 4. And then what that gives us when we do our common factor, well, first of all, 2x to the power of negative 5 divided by itself is going to leave us with 1. Oops, plus. And then 6 divided by 2 is 3. And now notice what happens. X to the power of negative 4 divided by x to the power of negative 5. Negative 4 minus negative 5. Negative 4 plus 5 becomes x to the power of 1. So what it will leave us with, and this is kind of the key idea here, what it leaves us with is a factor, a partner factor, that has no negative exponents. It's got positive exponents. Okay, that's the thing to note here. Note, we now have positive exponents. And again, sort of two general rules of thumb that I prefer is not to have any negative exponents and not to have rational exponents. So change your negative exponents to positive somehow and change your rational ones to, to become radicals. So I would continue with this one, and how would I change that? Right, so the x to the 5 is the only thing that drops down, right? The 2 stays up, 1 plus 3x stays up. I would move x to the bottom, and then it becomes a positive 5. Right? And that's what I would do. Now, in terms of your answers, like when you're looking at your homework, Some of them, they don't move them down. Some of them don't change the rationals to radicals. So, just again, recognizes a couple of different sort of ways to answer a question. Right? So that's basically the new thing. So try this last one. Right? Change the radical to rational first, so that you're seeing the exponents, and then use your greatest common factor technique. Excuse me. To pull out the greatest common factor. Because otherwise you'd look at that and go, well, the only thing that's really common is a 3. But now we can change, and anytime we've got a variable, we should be able to pull out something that is a common factor there. In terms of how much work you show, some of you can probably, maybe pull out factors a lot quicker, kind of do it in your head, and that's kind of okay. Excuse me. If it's helpful, right, change this to rational exponent, x to the 1/2, 6x squared, and now say, oh, well, I know that I'm going to be pulling out the smaller exponent, which is going to be 1/2. Right, so when you pull that out, you're going to be left here with 1 minus 2, and then here again you're going to subtract your exponents. So you're going to have 2 minus 1/2. Right, so 2 minus 1/2. Don't write it as 1.5, but rather write it as 3/2. And so that our final answer here, we actually pull out that common factor, right? And it's 1 minus 2, and then it's the square root. Again, the bottom number in our rational exponent describes the root, and then the top number describes the power, so it doesn't really matter where you stick that power. I'll put it underneath. So that's kind of what the final answer gets to. It's just a matter of how you sort of want to approach your way there. Question, Alex? So in other words, is this okay for your answer? So again, my comment would be, you shouldn't leave them with rational exponents. It's better to leave them in radicals. That's just a preference. It's fine. If this is your answer, good. Right? You've done it properly, and there's no rule that says to change it back. And like I say, as you're going through the homework, you'll see sometimes it's this way, sometimes it's that way. It really doesn't matter. And same thing with the negative exponents. When you're looking at your homework, sometimes the answer has a negative exponent. Again, I prefer to leave it as a positive exponent where possible. Mo, same question? Yeah. Okay. So this is fine, and this is also fine. Okay. So what's our common factor in the whole thing here? Okay, so x squared plus 5, right? It's that binomial. And what was the exponent? Okay, is that the smaller of the two exponents? To the negative 1/2. Now, that binomial, right, it's already got a set of brackets. So here's what I would do when I'm looking for my partner factor, right? Back here, I just put, a common factor up front, and then I put a bracket to begin my partner factor. So here, my common factor is already in brackets. So what I do, just for myself to make sure I know that I've got something different coming up here, open it with a big square bracket. Okay. So now, what should I notice? I should notice that I'm going to notice a couple of things. One of the things that we noticed was we now have positive exponents, so we should end up with positive exponents. We'll also end up with something else. What happens in that first one? Well, when you divide, you're taking this thing to the power of 1/2, dividing it by that thing to the power of negative 1/2. So we subtract the exponents, which means we're going to keep this x squared plus 5. And now 1/2 minus negative 1/2 is the same as 1/2 plus 1/2, which is 1. So not only will we kind of keep positive exponents, we will also, generally speaking, make them integral. I'll make them whole numbers. So this now has an exponent of positive 1. So don't have to write the little exponent of positive 1. Plus, and now the 3, and then these guys divide out, right? Because they are identical. So that's it. Now, hopefully you didn't stop there for two reasons. hopefully one of the reasons is you saw the negative exponent and you moved it. And then perhaps you also thought, well, there's a rational exponent, I should change it to a radical. That's fine. The other key thing is inside here, this x squared plus 5 plus 3, never leave brackets inside brackets. Always expand. Always expand. Okay? Because you never know, until you expand, whether or not you're going to end up with something else that may be a factor that can reduce somewhere down the road. Right? So that's just a general principle, is never leave brackets inside brackets. So on the top, we're going to have x squared plus 8. And then this other factor moves down and is acceptable, right, as either a exponential or a radical. So it moves down and becomes x squared plus 5 to the power of positive 1/2, which if you want, you can change it to a root. Excuse me. Okay, but that's the basic idea. Never leave brackets inside brackets. Now, if x squared plus 8 could factor, and then it could divide out an x squared plus 5 somehow, we would do that, but obviously not in this particular example. Okay. And with the last one here, okay, we also, when we're factoring, wherever possible, pull out any fractions. Okay, so don't leave the fraction as part of the partner factor. Pull out any denominators. All right, so this particular one, you could either do it in one step or you could do it in 2 steps. All right, by pulling out sort of the common factor. So as an example, let's say I'm not sure what you mean by that. So I'm just going to pull out the denominator part. In other words, I'm going to pull out the 1/3. And so if I pull out just the 1/3, the denominator part, then I'll get something, and then I'll look at that and see, well, what other factor can I pull out of there? Okay, so the first one, right, is just going to give us the 4y squared. But now the second one is not 2y. All right, it's actually going to be 6y. All right, because 2 divided by 1/3 is the same as 2 times 3/1, so that's 6y. Right, so that when we distribute it back through, we just make sure that we get what we started with. And then same thing, 8 divided by 1/3 is going to be 24. So you can do this in 1 step or you can do it in 2. We're doing it in 2 steps. And now you're looking inside that bracket saying, well, what's the greatest common factor now between 4y squared, 6y, and 24? Right? And it's still 2. Because again, if you look back at the original, it's the greatest common factor still between those 2 numbers, right? And so we should have, in a sense, pulled out 2/3. If you didn't see it initially, that's fine. Just take that extra step. It's, better to take 1 extra step and be right and be certain, rather than skip a step and potentially make mistakes. And so this now is 2y squared plus 3y minus 12. Okay. And now that we've kind of pulled out the denominator, the fraction piece, also look, does 2y squared plus 3y minus 12, does it factor? Does it break down? Right? Because now you do your kind of your trinomial stuff. Right? So as a review, right, we look for what 2 numbers would multiply to make negative 24 that would add to make positive 3. If there are 2 numbers that do that, we should keep on breaking it down. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So the answer is no. Now that doesn't mean that there aren't solutions if this were an equation. In other words, the roots that would come out of here, they're not going to be rational, right? Because it doesn't factor down, so we don't get rational roots. Are there roots? Like, in other words, are there x-intercepts? Ty's nodding his head. How do you know for sure? Right, perfect. Okay, right. The a value, 2y squared, means it's opening up. And then the negative 12 y-intercept means it's got to cut through that x-axis to then go through the y-axis down below and then back up. Right, absolutely. Okay, what if that was a positive 12? What would you do next? Does that guarantee then that it doesn't? Do you remember what would be the next thing to sort of go through? Right, yeah. Then you go through the discriminant, right? Remember that part of the quadratic formula, b squared minus 4ac? And we'll get to that maybe today, maybe tomorrow. All right, so that's it. We can't find two numbers. There are no two numbers. It's not that we can't find them, it's just that they're not there to be found. And so that's as far as that particular one goes. Okay. Don't have to worry about the 2/3. We have no negative exponents. We have no rational exponents. And so we're good there. All right, one more biggie. You ready? You're up for a challenge? Now that you're kind of warmed up, at least mentally, not physically. Whoa. Hello. Bring out the big guns. Oh, we got another one with bigger guns. Try this one. And then actually what I'll do is I'll bring the other one on here right away as well so that you kind of have two together. I know. Come on. Okay, so let you work at those two for a bit. See what you get. Okay, so this one here, just it kind of looks, there's a lot of stuff, but there's really not a lot of stuff. So first thing is multiply those negatives. Okay, so just change it to a plus. Don't have to rewrite it by putting 2x squared in front, or 2x in front here, 2x squared in front there. Just kind of recognize and look and say, well, what are the common factors that I have? So there's a 2x in both of those. And then there's the binomial 1 minus 2x with the smaller exponent. The smaller exponent is our 1/2. Okay, and again, I put a big square bracket that says now inside here, I should have two main terms, right? Because I've got this first piece, there's our plus sign, and then here's our second piece. So from the front, well, the two x's divide out. And then the binomial, I'm just subtracting the exponents. 3/2 minus 1/2 is 2/2. 2/2 is 1. So I'm just going to have here 1 minus 2x. Now, because it's the lead binomial, I don't have to put brackets around it. I did, but I don't have to. What comes next? Okay, so plus, and then the 2x's. Okay, so the 2's divide out. X squared divided by x is x. And then here the 1 minus 2x, the binomial piece actually divides out. So again, the basic idea is I don't want to have brackets inside brackets. So what we're going to have is, well, this 2x. This factor, again, we could leave it with the radical exponent, or we could change it to a radical. I'll change it to a radical. And then what about this one? Well, this one becomes 1 minus 2x plus x, which is just 1 minus x. And so there's nothing else that happens there. That's our expression. That's factored now. And it really, yeah, you could have left that as the 1 minus 2x to the power of 1/2. It's okay. I have a preference, but it doesn't matter. Okay, so that one wasn't so bad, was it? All right. Now, did you start this? Yes, no? You want to... Okay, so let's walk through it. Okay, again, on the bottom, I'm going to ignore that to start. I'm just going to work on the top, but I need to remember that I do have a bottom there. Okay, up top, I've got how many terms? Well, this whole big thing here is one term minus, there's another one of those subtracting a negative, so I'll make that into a plus, and then everything else there is another term. Okay, so now I actually see that I've got sort of three things that I need to work with, right? One is I want to take out that factor of the fraction piece, the 1/2. Nothing else in terms of the 3. And then I've got two binomials that are common. Okay, so I'm going to pull out the 1/2 first. Then I'm going to pull out the x plus 1 factor. Then I'm going to pull out the x squared minus 4 factor. Now, the x plus 1 factor, the smallest of the exponents is the negative 2. And the x squared minus 4 factor, the smallest of the exponents is the negative 1/2. Right? This upper one here, it's actually a negative 1/2. So I'm going to do that. Now we've got to open up that big square bracket and see what's left. Okay, so the 3x divided by 1/2, so that's going to become 6x inside there. And then the x plus 1 factor divides out, so that one's gone. The x squared minus 4 factor, that factor is going to have, let's see, x squared minus 4, exponent was 1/2 minus negative 1/2, so that becomes a positive 1. Okay, so I don't have to write that positive 1, I'll leave that factor as it is. And that's done the first major term, plus, okay, so the halves are gone. The factor of x plus 1 has an exponent of 1, and I subtract the negative 2. Remember, you subtract the exponents. So that factor of x plus 1 is actually going to now have an exponent of 3 on it. And the factor of x squared minus 4 had an exponent of negative 1/2, so that factor basically divides out. Okay. On the bottom, I've got a factor of x squared minus 4 squared and x plus 1. Now, a couple things, right? Number one is I can't leave those brackets inside brackets. So there's a bit that has to happen there, right? I need to distribute the 6x, and we need to expand x plus 1 all cubed, right? So we need to expand that. In front, okay, these 3 factors that are in front, we can actually begin to deal with them. Right? We know that, oh, see this x plus 1? The exponent of negative 2, we're going to bring that down, and so that's going to change that binomial, or that factor on the bottom. X plus 1 is now going to be on the bottom with an exponent of 3, right? Because the negative 2 comes down, becomes a positive 2. There's already a 1 there. 1 and 2 makes 3. Same thing with the x squared minus 4. That comes down and becomes a positive 1/2. So the exponent down at the bottom is actually 2.5 or 5/2, which we can deal with the radical. And then the other thing that can come down is the 2 that's part of this 1/2, right? With the 1/2, I can bring this 2 down, and that's still 1/2. So I'm going to kind of put all of those pieces together, kind of as I just mentioned. Okay, so the 1, I don't have to write the 1 anymore. I'll put the half down below. This x plus 1, when it comes down, gives us a new factor with an exponent of 3. Okay, just talked about that. The x squared minus 4, when that other one comes down, it gives us that, becomes a positive 1/2, so that's 2.5. So I said that was 5/2. Now, I'm not going to change it to a radical yet, just in case when I expand, I get something. All right, so what I'm going to have here is, first of all, distributing the 6x through. I'm going to get 6x cubed minus 24x. And then I need to expand that x plus 1 cubed, which if you can do it the short way, do it the short way. And if you can't do it the short way, do it the long way. All right? If you remember binomial theorem from 30-1 at the end there, kind of shake out the cobwebs a little bit. It's going to make a nice Pascal's triangle kind of row, right? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So this is going to give us a 1, a 3, a 3, and a 1. Excuse me. and now tidy up that top. All right, so tidy up the top. This is going to give us 7x cubed plus 3x squared minus 21x plus 1. And that's going to be our top. The bottom, we've got this 2 there. We've got the x plus 1 cubed there. We've got a sneeze coming on. Thank you. And so this to the power of 5 halves. And now you are hopefully asking yourself, okay, does that top piece factor down? And if it does, the only factors that we should really be concerned with are factors that look like x plus 1 or factors that look like x squared minus 4. Don't even think about x plus 2x minus 2, all right? So are we going to get a factor of x plus, well, are we going to get an x squared minus 4? Probably not, right? Because there's no 4 here. And are we going to get an x plus 1? Well, we could, because this ends in a 1. Remember the remainder theorem, factor theorem, and sort of that thing? In order to have an integral factor, it's got to be a factor of this one. So what you do is you're going to test. Do you remember what to test? If x plus 1 is your factor, test the negative 1 to see if x plus 1 is a factor. So negative 1 cubed, negative 1 times 7 is negative 7. Negative 1 squared is 1 times 3 is 3, and negative 7 plus 3 is negative 4. Negative 1 times negative 21 is positive 21. We're going to be nowhere near 0, right? Because that's what we're looking for. Test p of negative 1. If x minus 1 is a factor, remember that p of negative 1 then should be 0. That's that remainder theorem, factor theorem. And so we can tell that it's not going to give us 0. So that means that x plus 1 is not going to be a factor on the top, so stop, basically a z, right? That's the only thing we kind of would consider. And so we're, apart from changing that rational one into a radical one, we're done. Okay. So, good. Questions? Not sure. Good to go. Okay, so we'll walk through both x cubed minus 64 and x cubed plus 64. Using the sort of remainder theorem, factor theorem, can you think of an example of a value of x so that if we substituted it in here, that we'd get a value of 0? Yeah, 4, right? Like the cube root of that 64. If we evaluate this for 4 cubed is 64. 64 minus 64 is 0. Therefore, what's one of the factors? The factor, right? X minus 4. So, x minus 4 is a factor. Well, how do we find the partner factor? So this is kind of a bit of review concept of 30-1. How are we going to find the partner? Well, how else do you find the partner when we were doing the greatest common factor? What did we do? Divide, right? Absolutely. We divide. Okay, how do we divide x cubed minus 64 by x plus or x minus 4? What kind of process do we use? Okay, long division is an acceptable one, and the other one that's shorter. Okay, so you can either use long division, and it's good to remember how to do that. We will use long division in this course later on, and if possible, for this particular one, we want to use synthetic division. Okay, synthetic division works here. Later on, when we get into the course, the synthetic division doesn't work, right? Because synthetic division is a shortcut for particular types of division. All right, so let's do the synthetic division. Now, can we use 1x cubed minus 64? Can we do that? Good, remembering, okay? Okay? You must have all the descending powers there. So we've got 1x cubed, we've got 0x squared, we've got 0x, and we've got negative 64. Right? And now, the way synthetic division works, there's two processes that you can do. Okay? Personally, I do the addition one. And so when I'm using x minus 4 as the factor, I put the root of that divisor there. Okay? And if you do the minus 4, that's fine. Just recognize that I'm doing something maybe a little bit different. Okay? You must bring the 1 down. You must multiply the 4 by the 1 and write it underneath. And now here's where the two versions differ. Okay? Because I'm using the root, I'm adding. So 0 plus 4 is 4. And then I repeat. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. Negative 64 plus 64 is 0. Good, I've got the 0 there. That way I know that my division is done correctly and I've got the right factors. So, at this point, I'm just going to move this over here. X cubed minus 64 factors down into x minus 4 and x squared plus 4x plus 16. Okay. And now the question is, does x squared plus 4x plus 16 factor down? Right, so this is where I kind of asked the questions before. It opens upward. It's positive 16. Okay, well, not sure. And now you run the discriminant test, and it's b squared, so that's 4 squared, minus 4 times 1 times 16, which is too big. All right, you end up with a negative value for your discriminant. So that means that x squared plus 4x plus 16 will not factor and does not yield any x-intercepts. So this is how it factors down. X minus 4, x squared plus 4x plus 16. Now, before we look at sort of a shortcut, I want you to try the same process with x cubed plus 64. First of all, thinking, what number, if I evaluate it, will give me 0? Right? So it's the same 4, it's just that it's negative. So this is going to be p of negative 4. Negative 4 cubed is negative 64. So that means x plus 4 is a factor. So what I want you to do now is use your synthetic division, or log division if you want, and find out what's the partner factor. And then we'll see if we can put something together. So very similar in terms of its long division or synthetic division. You get x squared minus 4x this time and plus 16. And so it just so happens that in general, whenever you have a difference of cubes or a sum of cubes, very simple sort of formulas to what it breaks down to. And a doesn't just have to be a single variable. It just is something that is being cubed. Whatever it is, something that's being cubed. And same thing with b. So the difference of cubes, something cubed minus something cubed, what we noticed, hopefully, is that, well, the first thing you had is you had the cube roots and with the same sign, right? X cubed minus 64, the first factor was x minus 4. Cube roots, same sign. And then in brackets, what you had was, and there's a bit of a pattern here, it's basically the square of that first term, so it's a squared. It's the square of the last term, tucked at the end here, plus b squared. And then in the middle is the product of those two with the opposite sign. So this is a plus sign. Right? So if you look at the x cubed minus 64, you see x minus 4, and then you see x squared plus 4x plus 16. Right? And then a cubed plus b cubed, same sort of thing. You get the binomial that has the cube roots with the same sign. And then you get the squares. So a squared at the front, b squared at the back. And then you get AB in the middle with the opposite sign. And you can always check, right? Just in case you're like, oh, I can't remember. Is it plus, minus? What is it? You can always just multiply it through and check, right? A cubed minus AB squared. Whoops, there's the plus AB squared, which adds to 0. And then there's the plus AB squared. Here's the minus AB squared, which makes the 0. And then here's the plus B cubed. Okay, so you can always kind of just quickly double check that. So let's quickly do these together. All right, first one looks, at least up to this point, there's nothing to factor there, right? There's nothing common between 8 and 27 and A cubed, B cubed. Can't do it. But now, as of today, we're like, okay, we can do something here. First of all, we want to rewrite it, or at least rethink of it, as something cubed plus something cubed. Right? So you break them down. So 8a cubed is 2a all cubed. Right? Cube root of 8, cube root of a cubed. And then same thing with the 27b cubed. Are you making poor Ronnie laugh? Oh, okay. I saw that. Okay, so now that we've got our kind of our A and our B in a sense, right? We know that this will factor down into something multiplied by and something a little bit bigger. That first something is going to have the same sign, and it's going to be those cube roots. So it's going to be 2a plus 3b. In the second bracket, it's the first one squared, so I think 2a squared, so it's going to be 4a squared. The last one's the other square, so that's going to be 3b all squared, so it's going to be 9b squared. And then the middle is going to be the product of those two, so 2a, 3b, that's 6ab, with the opposite sign. Okay? That's all there is to it. Again, we can double check by multiplying to make sure that we get what we started with. But once we've kind of got that, you know, attacking it from a sum or difference of cubes kind of perspective, that's great. Okay, so now the second one, right? This is the one that you're going to use for question 4C, all right? This is the one that you're going to use for question 4C, because when you look at question 4C there, you've got, you know, you've got an x minus 4 on the bottom, right? In your denominator there in that question. And you go, that doesn't factor. Well, this is actually kind of maybe a little bit trickier then. That's not a difference of cubes, this particular one. But it may be, I don't know, once you've multiplied out. I think this is the difference of cubes. Another one is 2L. Remember 2L? 2L, there's a sum of cubes right there. So just keep your eyes open for those. So the key with this one is, can we rewrite this as a sum or difference of cubes? Well, sure. Here's our minus sign. Okay, well, that's the easy one, right? And then the other one is, oh, well, it's basically the cube root of x, right? Or x to the 1/3. Doesn't matter which one you use. You can tidy it up later, right? X breaks down into x to the 1/3 all cubed. And so now that it is a difference of cubes, we have two factors. One's a binomial and one's a trinomial. The first one is the cube root, which is x to the 1/3 with the same sign, and the other cube root. And then the rest of it is, okay, so you just go through. It's that first term squared. So x to the 1/3 squared is going to be, well, x to the 2/3. The last one is the easy one, and that's just the second term squared. And then the middle one is just the product of those two. So it's 2 x to the 1/3, and the opposite sign, which is plus, and we're done because we don't have any negative exponents. If we want to change them back to radicals, that is another step again that we could do. Right?
Keep going.
What's that?
Keep going.
Keep going. Oh, it doesn't factor anymore. No, it doesn't. Cube root of x minus 2? Well, yeah, you could technically factor that now ad infinitum if you want, right? Difference of cubes. Keep going, keep going, keep going. Right? But we'll stop here. Okay? So that's kind of a new factoring sort of thing. Would it be helpful? I mean, you know how to factor trinomials? That should be familiar. Factor theorem, synthetic division, we've touched on. It's okay for that. Then let's jump and just kind of look at, let's look at, we've got enough time maybe for 2 examples of solving equations. Okay. Okay, so let's jump to, nope, that's, there, this one. Okay, so let's solve. Okay, so we're going to solve one that's not a rational equation, and then we'll solve one that is a rational equation. You bet. Okay, so remember that when you're solving equations, basically you're trying to, at least if it's quadratic, set it equal to 0. Right? Set it equal to 0 and use some previous skills, right? Factoring or what have you. Right? And remember that when you're asked to solve, you're looking for finding the value of x that makes that equation true. So our first piece there is gather everything to one side so that it is set equal to 0. And now try and factor. So can we think of 2 numbers that multiply to make -10 and add to make -1? The answer is I can't think of any. But just because I can't think of them doesn't mean they aren't there. Okay. But there are no 2 numbers, so it's not going to factor over the rationals. Okay. Going back, will this produce any roots? Right. So the quick look, a value is 2, the c value is -5, so yeah, it's going to cross. So here we need to, and we don't even now need to use the discriminant, but we just need to carry through with that quadratic formula. All right, so, and you're given the quadratic formula on your formula sheet, but not for, maybe not for the pre-calc. I don't know, we'll see. So minus b plus and minus square root of b squared minus 4ac all over 2a. So 2a is 4. And so now inside here we want our discriminant b squared minus 4 times a times c. So 8, 40, 41. Okay. And then if you could break that radical down, right, or simplify it. If there are common factors between the 1 and the coefficient and the 4, you would factor that out. But this particular one, whew, that one wasn't so hard. I mean, it wasn't so long anyway. So again, when you're looking at the homework, some of those then should be fairly straightforward. And then let's just look at the last one. Okay, unless there are any questions, I don't want to go too fast here. Okay, good to go. So the last one that we'll stop with here, nice little rational one. Okay. And the basic idea, remember, when you have a rational equation, is you want to eliminate the denominator. You always want to make this simpler rather than more complex. So eliminate the denominator by multiplying by the lowest common one. Right? You want to create an equivalent equation just one that doesn't have the denominator. And so here, this one's fairly straightforward. The only two factors that you have down there are 2 and x minus 7. Right? If you have more, it's kind of combine them together, but use that lowest common one. And so then we want to multiply that by each of the terms. So we've got 1, 2, we've actually got 3 terms in this equation. And again, we're multiplying by that lowest common denominator so that we can eliminate. Right? In other words, the x minus 7's divide out. And we're left with 2 times 2x minus 9, which if you want, you could distribute through right away. I'm just choosing not to yet. And then here plus, again, x times x minus 7, which again, you could distribute through right away. And on the right-hand side, you'll have, well, the x minus 7's divide out, so you'll have 2 times 5. So I will multiply that out, get 10. And now, no denominators left. Hopefully this is going to be a quadratic or a linear function. We'll see what we get. All right. So it looks like we're going to keep the quadratic. Doesn't look like that's going to go away anywhere. So I'm going to move everything to the left-hand side. So x squared, I'm going to combine 4x minus 7x. And now I'm going to subtract 10 from both sides. So that's going to be minus 28. And now when I factor, two numbers that multiply to make negative 28, which add to make negative 3 are negative 7 and 4. And so we get two nice and tidy solutions. X equals 4, or sorry, x equals 7 and x equals negative 4. Right. Okay, I was going to say, thumbs up. Are we good with that? The answer should be no. Right? Anytime that you have certain types of equations, we have to be careful. Right? With radical equations, we have to be careful. With rational equations such as this, we need to be careful. Right? Namely, we need to look at our denominators and state our non-permissible values. Okay, so our non-permissible value here, x cannot be 7. Because if we let x equal 7, then we're dividing by 0, and division by 0 is not defined. Right? So in terms of our solution, x is equal to negative 4 only. The 7 is considered an extraneous root. Okay. So I think that's enough work for examples. There are a couple of examples that are on the, they're in the notes that we're not doing. If you really want to see them done later on, that's fine. We can do them, or you can refer to, look back at one of the previous semesters notes for those, because even with my other class this semester, I didn't do them all either. So your assignment is at the end here. It's also on your homework sheet. That is to do 2L now and 4C now, as well as 5 through 7. Okay, and because because you see me only every other day, try and keep as current with the homework as you possibly can. Well, it means do it, and do it now. That's basically what it means. It means you shouldn't be falling kind of too far behind and saying, oh, I'll leave it for another day. Now, granted, I don't know all of your lives and what busyness you have at any particular point in time, but try not to fall behind. That's what I would say. If I were your parents, that's what I would say. Try not to fall behind. Yeah. So for this particular unit, let me just kind of close off here. We're done the lesson. Great. Goodbye.